Hello, folks. This is Nick Ronconi with Applied Tech Systems. It's the top of the hour and time to start our webinar. No matter what time zone you're in, I just want to thank everybody for attending today. We'll be discussing moving from a paper-based inspection and usually Excel or other application analysis system to a digital system. In the 25 or 30 minutes that we'll be spending today, we'll be first discussing what the basic advantages are to digitalizing your inspection system. Then we'll spend the bulk of the time actually working with the software package for collecting and analyzing data. So we'll look first at what it's like for your inspectors and operators to use a software interface for entering their defect, repair, and other quality-related data. And then we'll take a look at what analysis is available through an application like this, and you can see if that would be helpful to your foundry or not. And then lastly, we'll take a look at where savings will occur. And we'll provide you with a form that will help you calculate what your current cost of quality is and see where the savings might be. So without further ado, we'll start in. There is quite a bit of inspection activity taking place in most foundries. The diagram I have up here is representative of a investment casting application, but it would of course apply to both sand casting, permanent mold, die casting, etc. There are various inspections taking place throughout any casting process. Here, if I stick to the theme of an investment casting application, the inspections take place before parts are produced. Generally, folks are creating wax models. You can see that I have magnifying glass with checks located at places where inspections take place at quality gates. Usually there are inspections of the actual individual wax models of the parts themselves. Then when those get treed up, there's inspections that take place of those trees, usually both by a human with visual inspection and then perhaps using a borescope or some other type of equipment. After those have been dipped in the ceramic tanks, there's generally a look that's taken at the investments or the shells themselves. The parts get made, and then if I move on, after the parts come out, there's generally knockout or shakeout. The parts may be cleaned up a little bit. Then there's visual inspection stations where the castings are inspected. If you work in an aerospace type of an environment and you have expensive castings or complex castings made out of titanium, magnesium, etc., a lot of times there is an opportunity to repair the parts, do some welding and blending, etc. Even if you don't repair the parts, generally if there's some minor defects like removing flash or grinding a gate off, that type of thing, that process or an actual weld and blend generally means that after the parts have been worked on, they cycle back either through visual inspection or else they go through a more complex type of an inspection such as FPI or X-ray, etc. Many foundries these days have added value departments where they're doing CNC work or maybe some light assembly. There might be some inspections there. And then, of course, if you've shipped a non-conforming product to a customer and they have to return it or you have to go on site to a customer, there's generally data collection that takes place and then follow up with like an 8D or some other process based on that data. So as you can see here, any foundry is going to have quite a few different locations where data is collected. This data is often collected by hand. It's kind of interesting that with manufacturing 4.0, I'm sure your process engineers and your operations folks are investing quite heavily in connecting to their PLCs and their sensors and everything to get process data. But yet studies show that about 70% of the actual product inspection information is still collected by hand. So if you do move to a digital system, you'll be closing the loop per se in having all of your information, both process and product, in a digital format, which of course makes it a lot easier to work with. If you are collecting data on pieces of paper, some of these probably look familiar to you. I just put some very common formats for inspection forms. On the upper left, you see the common tick sheet where you might just be putting marks on a form. as far as what kind of defects you're seeing to try to get a handle on that. On the bottom, you see just a standard checklist, maybe a mix of actual measurement information and confirmations of things like ID stamps or etchings, as well as some visual inspection. The one on the upper right, the largest one, is probably what I see most in foundries. Generally, it's important to know both the location and type of defect. So many times a paper inspection form takes on the look and feel of a picture of the actual product, and then people mark down, as they have here, where a burr has been marked on the actual graphic. I'm sure a lot of you are familiar with another type of this form, which is some type of grid, maybe a 10 by 10 grid laid over this. Then multiple part datas are mixed on that form with the grid, and then you go to your process engineer and say, hey, a lot of our porosity is located in grid location A3. So again, if I am collecting data by hand, and then the next step is keying that data into Excel or some other type of maybe a homegrown system or an ERP or MES system, there are several downfalls with this whole process. Number one, if I am collecting data by hand and then keying it into another application, there's always errors associated with data handling. Generally, a piece of paper or something homegrown isn't elegant enough to allow you to really get all the information you'd really like to have to drive down defects and make long-term process improvements. And then if your analysis system is actually based on Excel, there are fallbacks, of course, in the sense that if the one person who put that Excel analysis package together using pivot tables and such leaves or moves to a different job, those systems often fall by the wayside because there's no one left who knows how to actually maintain that system. ERP and MES systems, if you're using SAP or Odyssey or something along those lines, those are great generally for production and financial reporting, but not so good for quality people or process engineers because they really lack the analysis that you need to drive down defects. And then, of course, anytime I'm handling this data, there's lag time, and lag time in identifying a problem means that I have a lot of non-conforming material that's built up in my work in process, which of course adds to my cost of quality. And then lastly, usually you just can't get the analysis you need through an MES system or Excel, such as analysis by cavity or other factors to drive down your defects. So having said that, what we're going to do now is spend about the next 10 minutes or so taking a look at a digital application for collecting and analyzing data in a digital sphere. What we're going to be using is a software package called ATS Inspect, which is a pretty popular package at foundries. The software itself for data collection can be run on both a tablet or a fixed station. That's important for you to think about. If you're inspector-based, you'll probably want to have something that runs on a portable device. And if you have fixed stations, say at a scrap dispositioning area, maybe a fixed station is the way you want to go. And after we collect that data, then we'll take a closer look at the analysis. This software has a web-based analysis package with a lot of reporting, and we'll see what's possible to help you there. So having said that, let's move now to the data collection application. Usually you have a couple choices when you move to a digital system. You can hire a company typically to make a specific digital package that meets your requirements specifically. That tends to have a higher cost of quality as time goes on because anytime you need a change, you need to get changes to that system through that vendor. The other option, which is what we're using here, is a configurable off-the-shelf package. So what I'm showing you here is just the way this interface has been configured. Generally, a digital system can be reconfigured to match up specifically with the kind of data that you want to collect. So generally, there's some type of login, which I've already done. One of the advantages of moving to an electronic system is you can really leverage a lot of the other technology that's out there. So as far as logins go or other types of data that's entered, if you have things like barcode scanners, badge readers, optical readers. The nice thing about using software to collect your data is you can really leverage that technology and enter data through barcode scanners, RFID tags, etc. So I've already logged in. I'm going to select a part here for inspection. And again, here you see a list of various categories of parts at the top. I'm going to, of course, go to the casting area. When I select castings, you'll see some part numbers that appear down here. This is merely one way that I'm using to collect my data or select my part. You could scan a barcode or other method as we have discussed. So there are a couple of different ways to enter data. If you remember looking at the paper sheets, there were checklists, for example. Then there was a sheet that had a graphic of the part. So first, let's take a look at what it's like to enter data through an electronic interface on a graphic. The nice thing about this particular software package I'm using now is the graphic can actually be a CAD image. So you can see this is a live CAD image. I have the ability to either rotate the part by grabbing the corner in order to get the orientation I need to enter a visual defect that I'm seeing on the part. If you look over here on the right, you can see that I have these what we call thumbnails, which as I click on them, you'll see the part rotate to a predetermined orientation. The nice thing about using a CAD image, and again, an advantage overall of using a digital system, is most of you are using, let's say, Team Center from Siemens or Unigraphics or something along those lines for managing your CAD graphics, and you can just import those graphics right into a software package. One of the other advantages there is usually if I have a solid cast part like this, it's broken down into different areas. If you look in the bottom left-hand corner, you'll see that right now, based on where my cursor is, it says part location front knuckle at the bottom of that window. You'll see if I move to other areas of the part, because this was noted in the CAD image, the software knows that this is a suspension arm knuckle, this is a tie rod arm knuckle, etc. So later on, I can analyze my defects by area of the part, which is usually very valuable. You also have the ability, by the way, you see I have this zoom button down here. So if I really want to hone in, I can magnify a portion of that graphic, and then I can really locate that defect exactly where it is on the part. I'm just going to go back to full image here. So let's say I see a defect. If I'm using a touch screen, I can simply touch the part, or I have the ability here to click on the part as I'm doing with a mouse. The nice thing about a digital system is, unlike a paper system, if you're using free-form comments, a lot of times you have a problem where people are calling defects different things. Here I have the availability to have a predetermined list of my own vocabulary of defects. So after I touch the part location, we're capturing the XY location on that graphic, and then I can pick the actual defect that I see. We'll pick cold shut here. Now, the nice thing in terms of getting additional information is you can see here, I have a screen come up where I can actually rank the defect. So for example, if the cold shut was bad enough, I can scrap the part, or if I can grind it out or otherwise repair it, maybe I just have a rank of major. So I'm going to pick a rank. The software also has the ability to do things like assign a responsible cell and area. Again, you don't have to do this, but I'm just showing you some of the capabilities that are possible. So here I'm going to say that this was actually coming from Op 110. Some folks like to enter free-form comments, which I can do here. So I can type in anything I'd like to. You'll also notice that there's a graphic here, and I have the ability to leverage the technology of having a integrated camera on my computer or my tablet, and I can actually take a photo of the actual defect and attach that photo here. So that's another advantage. How that works is, you'd see I would just click on this, this camera image here. Like most folks on Earth, I have a sticker over my camera, so you just see an orange background here, but let's say that was a picture of my casting. I would just add that to the record, and you'll see here that that photo is now attached to my inspection record. So you can really get a lot of information attached to your inspection record. So if you're an aerospace caster, or you want to do an 8D or troubleshooting later, you can have quite a bit of information between the comments, the photos, etc., and the graphic with the actual defect. You can really get a nice record of what's happening on your castings. So I would just continue to collect this information. Again, I would just touch the part. I can touch the defect here, porosity. I can enter in that other information or not. I can rotate the part. So when I'm finished, I just move on to the next part. Other things that are nice is you can see here I have some documents associated with my inspection. This is very helpful to have things like job aids. Maybe for your inspector, you want to have an example of what porosity looks like, as I have here. You can have, let's say, job aids, or more comprehensive, as I have here for forged or cast parts, that list various defects, what is acceptable, what is not. I also have the ability to send quality alerts to the floor. So if you have a known issue or something that you specifically want your inspectors to check for, you can certainly do that. All right, so that's entering defects against a graphic of your part. A couple other things I want to show you here is, let's say you're actually entering some measurements. You can have a checklist. Here, for example, I have a checklist which is configurable by you. The first question in my list is the ID stamp legible? You'll also see that for each checklist question, I can have a job aid pop up like I have here on the left, showing me what the ID stamp should look like. These checklist questions can be yes, no. Here I'm going to say yes, looking at the part, that ID stamp is clear. Maybe I had a rejection in the past or a known problem, or I have to check for scale in a hole. So the correct answer here, for example, would be no. So I'm going to say that as I look at the part. Here I'm going to take a series of measurements. You'll see that I have a job aid pop up here with a print. I can enlarge that print, so it really gives a nice reference document for the person doing the inspection. As I move through these measurements, I can either enter the data by hand, or I can have that value entered directly through a digital gauge like a caliper or a micrometer, etc. So I enter in the value. If it's in spec, you'll see I get a green check. I just move on. On the next measurement, if I take that measurement and it's 87, comparing that to my spec limits, I see that that's out of spec. So this gets logged in as a non-conformance, and you can have a custom message like you see at the top be displayed to the inspector. I'll put in this next value, 78. That is also in spec. And then you can have multiple choice questions as well, such as, hey, what material heat is this? And I'll enter that. So between the checklist and the entry of defects on a graphic, you can pretty much match up to any type of inspection you're doing with paper and pencil now. You can also have ongoing reports available to your inspectors. You can see here I have an automatically updating chart just showing me the top kinds of defects I'm seeing on a regular basis. All right. So that's a quick look at the data collection. What I'm going to do now is move into the reporting. So basically, all the data from your quality gates will go into a database, and that's available on a real-time basis, making it easy for you to react to situations and reduce your non-conforming material being produced. If you're using serialized parts, or even if you're not, every part that data is being entered on can be appended in a single unit history. So in this interface for looking at reports, you'll see a library of reports on the left-hand side. So the first thing I do is I pick the actual report type, here that's single unit history. So in my example, I'm going to have a situation where maybe a customer called me and said, hey, Nick, we have a problem with serial number 51822. So when I pick that report, the single unit history, or any other report, on the right-hand side, you'll see a window pop up where I can sort or filter the data that I want to use to populate that report. So here I'm going to type in the serial number 51822 that I want information on. I'm going to move these panels over to the side to make the report bigger. When the report renders here, again, this is all of the information associated with the inspections that have taken place at the various quality gates as that part moved through the process. So you'll see here at the top, you have a part number. If there's a serial number, you have an ID, as I do here, 51822. If you had other information such as a material heat, a cavity, an inspector, a shift, all that would appear here. You'll notice that I have a time and date stamp and a duration of the amount of time each inspection or repair took. You'll see that I have a graphic noting the locations of the defects as to whether or not they were repaired or not. And then if I go to the second page of that report, you will recall that I entered in some measurements as far as different types of things from gauges. I also had some questions such as an ID stamp legible, etc. You'll see the results of those checklist questions. And again, I get the name of the person who did the inspection or the repair. All that information is captured for me. So that is a single unit history. Each part has a single unit history, but then all of those single unit histories are in a database, which then allows me to look at what I would call an aggregate report. So for example, as a quality manager, you might say, geez, out of all the parts that have run through my foundry in the last month, week, whatever, I'm gonna look at a product ranking. So this product ranking, which I pick on the left, is a type of report, which is gonna be a Pareto of all the different products based on how many defects have occurred on those products. But over here, you can see I can filter. I can pick a time range such as this week, today, last month, all year, etc. They're nice things. We're here down in the product selection. I see a list of all my different products. I can pick an individual product or a group of products and other types of examples like what shift it was on, a cavity, ranks, things along those lines. Once I pick my type of report and my filter criteria, I can then run the report. So again, here what I'm going to see is for the time and dates I've selected, which is month to date November, I can see that, wow, the knuckle is really the biggest defect producing part that I have. Well, if you're using paper and pencil and Excel, this is typically all you get. What's nice about a digital system is these usually have a very rich reporting capability. So here you can see these links down here, or just by clicking on this knuckle, I can then drill down a little bit. And if this was an assembly, I would see the various components in that knuckle. This is just one solid part, but as you'll recall, the areas were broken down into different areas on that CAD model, so I can see that most of my defects are appearing on the suspension arm area of that part. There are other similar reports available. Here I can pick up a concern ranking. So again, I can put my filter criteria in. I've selected the exact same time and date range of November. And now what I'm seeing is for that time and date range, I can see that cold shuts are my biggest issue. I can click on that bar, and now it's going to say for the cold shut, which one of my parts has the most cold shut? It's the knuckle. So I can come in the morning and I can know nothing about what happened yesterday, and I can instantly find out what my biggest problems, defects, type of scrap is, and then I can drill down to get more information. You'll also see things on here. It's easy to pick, let's say, defects by shift and concern. So when I pick that report, the nice thing about having a database and a rich reporting package is I can actually get a report like this, where it shows me my defects along the bottom indices, and it shows me that, for example, with cold shut, I have more of a problem on the afternoon shift than I do on the day shift. Now, moving to the last type of report we're going to look at, most of the time in a foundry environment, you really have to know the location of the defect as well as the type of defect. So here, because we're entering defects against a graphic, you can see here, I have that CAD image, and this report is doing a concentration diagram on demand. You'll see here over on the right, I have this mapping of cold shut against a part. I have laid a 10 by 10 grid over this. I can actually change the granularity. So here I've gone to a 12 by 12 grid, and I run that. And now I can say I want to see either all of these defects or I can hide all and just pick here. For example, I want to see where my porosity is. And it's a beautiful report. Imagine going to see this with your process engineer, literally rotating a virtual part, a digital twin per se of your part, and now I can see exactly where my porosity is showing up. I don't have to pick porosity. I can go to any other one such as cold shut, and I can see here that most of my cold shut is appearing where this red balloon is on the part. There are other reports too. That's a concentration diagram. You can also do a scatter. So again, first I pick the type of report. Then over here on the right, I'm going to pick that knuckle. And then I'll run the report. And now what I see on the part is a different icon over here on the right for the different types of defect. And again, this is very important for a foundry. Here, for example, I can see a concentration of cold shut. Well, you know, the most common cause of cold shut is a problem with my gating structure. So being able to see not only that I have cold shut as a problem, but where it is allows me to then look at my gating and see, hey, do I need to make a change in how I'm doing my gating? Something like flash is similar. Really, it helps to know where the flash is. That lets me know if I have insufficient weight on the mold or improper clamping of the flask, things along those lines, by knowing both the location and the type of defect. So I hope you've got a look at the analysis here. In the last 5 minutes, what we're going to do is take a look at where the savings come from in a I'm not sure I understand. In a system like this. So really, I equate this to finance type software. Your financial folks haven't touched a piece of paper in years. How they save money by using accounting software is they get better information on a more timely basis. Software like this is very similar. Here's an actual page out of a cost justification from an aerospace customer that was making investment castings. And you can see here, they piloted their digital system in the wax model area. And by having better information to work with on a more timely basis, they were able to achieve a 40% reduction in the number of wax patterns being repaired for their biggest defect, which was trapped air. So again, it's that better information on a more timely basis that really allows you to get a payback on the system. So let's talk about payback a little bit. In the last couple of minutes here, we'll take a look at a form that I'll be sending to all of you who attended the webinar. So how do you put a handle on your cost of quality? Well, here I have a spreadsheet put together. It's broken down into different areas like direct labor savings associated with handling your data from a paper system, reductions in scrap and rework, reductions in sorting. So for example, this form allows you to put in your actual data. So here, for example, if I had if I'm spending 15 hours a month, for example, let's just change that to show you it can be changed. If I'm spending 20 hours a week key punching this data, I can put in my labor rate, let's say $17 an hour. You can see here in this column E, it calculates my monthly cost. Well, if I'm doing this through a digital means now, I can see that, well, probably 75%, let's say 90% of that is going to go away. And you can see over here in the last column, it calculates your monthly savings. Well, I can do that for other activities. Here, for example, let's say I have a scrap rate of 4%. If my monthly production is $1 million, that scrap cost is $40,000. If I'm being very conservative here and saying that I can achieve a 10% scrap reduction, the $4,000 a month savings is what I would realize. So you can go through the other areas here, such as hours per month on sorting. So here again, I can put in, let's say 20 hours per month, my labor rate, and the software will calculate that. If I reduce my sorting by 20%, it calculates my savings. So that goes all the way through this sheet. And then you can even put in a cost of the digital system you want to purchase, some ongoing costs, and this form will actually calculate an ROI and a savings for you as well. All right. Well, we've taken about 28 minutes here. We've reached the end of the actual webinar. I want to thank you all for attending. Right now, we'll open up the floor to any questions. You'll see a box, and you can type in any questions you might have, and I can address them at this time. Also want to let you know we'll be sending out a follow-up email from the webinar, and you'll get both that cost of quality worksheet, a brochure on the Inspect software that we took a look at today, and hopefully you'll find that information useful. If you want to take a more personalized view of what a digital system could do at your particular foundry, you can contact me, and you can see my contact information here at the end of the webinar. All right. Well, I don't have any questions coming in.
Sorry,
I want to
Nick,
thank.
there is a question, Nick.
Oh, okay. Sorry.
How does ATS Inspect integrate with existing ERP systems such as Guardian software?
Oh, that's a good question. What I would like to say is probably about 90% of our installations are integrated with ERP, MES, or other quality systems. Generally, those systems all have mechanisms such as OPC, XML. They have the ability to take in or out a text file, and it's very easy using the open database within the ATS Inspect software to either pass data to those systems or to receive data from those systems to assist with the inspection point. What we generally do is look at each individual's company's system, and then we decide what work needs to be done, and we perform that integration. All right, I want to thank everybody for attending today, and again, please feel free to contact me to take a look at your specific situation. Thank you very much. Bye-bye.